Library for tonight's event, both in person and virtually. For this program brought to you through a partnership with Ames Public Library and the League of Women Voters of Ames and Story County. I'm Kathy Cooney. I'm an Adult Services Librarian here at APL. And the library's mission is to connect you to the world of ideas, which we do through diverse and inclusive resources and programs like tonight's event. I'll turn it over to John Klaus to introduce our speaker this evening.
Well, good evening, everybody. I'm John Klaus, and I am the program chair for the League of Women Voters. And it's my pleasure tonight to introduce our speaker. Tonight's program is on climate change, a problem we've been aware of for a very long time. The famous Prussian naturalist Alexander von Humboldt wrote a paper on the effects of burning coal for energy to run steamships and locomotives, that it was warming then, it was warming in 1831, and it would continue to warm our atmosphere ever since. So, what do we do about this? Well, we're having a real problem dealing with this inconvenient truth. Jimmy Carter put solar panels on the White House. President Reagan took them off. So we go. So what do we do? What should we do? Well, tonight's speaker will give us some ideas, I think, or at least some information and thoughts. Tonight's speaker is Dr. William Gutowski of the Iowa State Department of Geological and Atmospheric Science. He received a Bachelor of Science in Physics and Astronomy from Yale in 1976 and a PhD in Meteorology from MIT in 1984. And he has done extensive work in climate modeling, which should give us some insights as to what we could expect, and he'll give us some thoughts on what we should do. So with that, Dr. Gutowski.
Well, thank you. Thank you for that nice introduction. Thanks to all of you who've braved this weather, this wintry weather, to come out here tonight, and also thanks to all of you who are tuning in to watch this at some point later on. And my special thanks to the League of Women Voters and Ames Public Library for giving me a chance to talk about a topic that's very important to me. So yes, my title here, Climate Change in Iowa, How We Got Here, How We Can Choose a Better Future Together. And that word together is going to be really important in what I lead up to. I want to give some thanks to some of my colleagues. Linda Schenk, she's a professor in English. You might say, what does that got to do with climate change? I hope I can make that clear as we go along. Christy Franz, who's in my department as well. Brandon Feisel, who is a postdoc who's worked with me for a while, and many, many others who've worked together. This research like this is very collaborative, and you need a variety of people with a variety of backgrounds, and ultimately, it's going to take all of us to really address this problem. So, with all right. Uh-oh. Oh, 1 second. I see. There's something on my computer that. Oh, now let's see if it'll. Everything was working just fine about 20 minutes before. Let me see if I can. Here we go. Let's see if this works. Yes. All right. So key messages that I want to leave you with tonight, and I lead up to all of this. Climate change has happened, caused by humans. Change will continue to happen. We have many choices to make, and the best choices will engage the authority of everybody. And I want to emphasize that word authority. Everybody, every one of you here has your own authority. It often doesn't get recognized. Part of our work is trying to make sure that everybody does recognize the authority they have to bring to the table in all this. It takes all of us. Or as that old phrase goes, it takes a village to achieve something meaningful and long-lasting. So, my outline here, what has happened in the past leading up to the present, what we expect to happen in the future, but maybe especially important, how we can work together, and a little bit about some opportunities along the way as well, but especially emphasizing this issue of how we can work together. So the basic fact is our planet is heating up, which it sounds like you all well understand. Global temperature is rising. These are a couple of graphics showing decadal average temperature going back from 1850 up to the first decade of the century. That's year by year values. I'm going to come back to this figure in a minute, but the key point here is things are just going up and up and up as we go through the 20th century into the 21st. Most glaciers are melting. What this is showing here is the mass loss from glaciers going forward in time from about 1960, when they started making these measurements, up to early parts of the 21st century. And these glaciers are melting. Where does that water go? A lot of it has gone into the ocean. It's contributing to sea level rise, which I'll show you on another slide, but not this one. Arctic sea ice is shrinking. So this is the average monthly sea ice, Arctic sea ice extent. This is for the month of June. It goes through a cycle throughout the year. Some months it's higher, some months it's less. But in any given month, if you focus on any given month, there's been this downward trend. This goes back to early 80s when we started having satellites that could look over the Arctic Ocean and give us a measurement of the extent of the ice every year. I also want to emphasize that it's not just a simple downward slide. There's all these fluctuations from one year to the next. And that is just a sign that there's other things that happen with weather, that weather is always happening. Things always fluctuate. And the smaller the area you look at, the more that noise, if you will, comes into play. But you could still see trends that start to show up. So the sea ice is shrinking. Sea level is rising. This is with a reference point back around, 1800s, where sea level has been changing going forward in time over that long period up to close to the present. And the spread here is because the tidal gauges that they measure it with are scattered around, and they have to make some estimate of how much it's representative for the planet as a whole. But the main point is that sea level is rising. It's rising because water from those glaciers is melting, and it's eventually making its way into the ocean. And also the oceans are getting warmer. And it may not have warmed all that much, but when you've got an ocean that is about 4 kilometers deep, whatever that is, it's about over 2 miles deep on average. You heat it, you warm it up a little bit, the water's going to expand some, and that's also contributing to this sea level rise, which is very important. All these things are happening at the same time. And then finally, this picture here shows the growing season. This is for Iowa, the growing season in Iowa. And there's a general upward trend, but you also see all these fluctuations. These dots are the length of the growing season in different years. And that comes back to that point I was making earlier, that when the more and more locally you get, the more you have different fluctuations and variations. When you start to average things over the entire planet, they kind of average each other out a little bit. But that means that there's all this what I would call noise in the system, and sometimes that can act to obscure what's really going on unless you take a step back and take a look at a long-term record, and then you see, oh yeah, something is happening here that you may not have noticed otherwise. But it's always important to keep in mind that there is that noise out there as well. Those year-by-year fluctuations are going to happen. Just like we've had this rather cold weather just tonight, where we had that cold snap just before Christmas as well. It doesn't disappear, but there are upward trends. So this goes back now to that picture I showed you before, but now it's expanded. This is the average temperature for the planet, starting way back in 1850, when we had enough thermometers scattered around the world that we felt like we could have a reasonable estimate of what the global average temperature is. And these bars here are the average over 10-year periods, decadal average temperatures, and you can all these other little dots here are the values for individual years. But what you see is both the little dots and the bars especially are going up and up and up and up as we go through the 20th century. A little bit of a flattening out here. I think that has a lot to do with the fact that industrialization in World War II caused a lot of soot to get in the air, which has a small cooling effect. But by and large, things have been going upwards, and they've continued upwards, especially to where we are now. So our planet is heating up, and the past decade, as it says, was the warmest. And what's causing the change? Might be a little hard to see, but what this says here is the atmospheric concentration of carbon dioxide in recent decades exceeds by far the natural range that occurred over the last 650,000 years. We can make a measurement, if you will, of where the greenhouse gases were, how much greenhouse gases were in the atmosphere going way back in time by looking at ice cores, which trap little bubbles of air. With careful analysis, we know what was in the atmosphere by measuring those little bubbles of air going back as far as 650,000 years, and I think some people have been able to stretch it even farther back. But the main point is these graphs show for different things, carbon dioxide on the top, methane, another important greenhouse gas, nitrous oxide, another important greenhouse gas, going back to 10,000 years ago, and things are sort of fairly steady. Then you get up close to present, and all of a sudden things spike up. And these little insets just sort of show little zoom in on a particular period of time. But the main point is these things have spiked upwards, and they've spiked upwards because of human activities, burning fossil fuels and other human activities, but especially burning fossil fuels, and that's led to this big increase in recent, really over the past century or more than that. So, and that's, probably can't read this clearly, that says there are clear signs that humans have caused the increase. We know that humans have caused this increase in large part because scientists can make these detailed measurements of some of the detailed characteristics of the carbon molecules, the isotopes, for those of you that have studied this at some point. And the isotopes show that this is carbon that's been buried under the ground for a long time and then getting up into the atmosphere. So that's probably the strongest indication that says, yes, this is human caused. It's not some natural shift that's been occurring that humans have nothing to do with. It's very much caused by the release of burning of fossil fuels, by taking carbon that was buried below the surface for many, many millennia. I'm not a geologist, so I'm not going to get the time period right, but going way, way back into the distant past, and then it gets released. And so they can tell that this is from the burning of fossil fuels. So to summarize it all, the Intergovernmental Panel on Climate Change, the IPCC, has said it's unequivocal that human influence has warmed the atmosphere, ocean, and the land. This is from the most recent report in 2021, one that I had the great pleasure and honor to be working on with people from around the world. It's a very exciting and interesting experience to be part of that. And more specifically, they say it is indisputable that human activities are causing climate change, making extreme events, including heat waves, heavy rainfall, and droughts, more frequent and severe. So there's this irony here that we can get heavier rains leading to flooding, but also increasing droughts. And if you want to know more about that later on, I can talk about that in more detail. But you can end up getting both increased flooding and increased droughts going on. And we've seen signs of that happening already over the past few years in various places around the world. So what's been happening in Iowa? This shows the winter temperature change. Recent decades, 1986 to 2016, minus the first 60 years of the 20th century. So what we see here, the shading shows that here in Iowa, right here, temperatures have actually been going up. Temperatures have gone up a fair amount. This is the average temperature for the winter compared to the first part of a little more than the first 60 years of the 20th century. So temperatures have been going up. It's been warming. It's been warming due to those increases in greenhouse gases. And there's some various things that have been happening related to that. This shows what happens with cold snaps. Here, I did this computation for Ames and also for Cedar Rapids because of some people I was talking to there at one time. It shows severe cold, what I might call a severe cold snap. You can define a cold snap any way you want, but the way it's defined here is 5-day periods where the average minimum temperature is less than minus 15 Fahrenheit. So very, very cold over a 5-day period. First 50 years of the 20th century here in Ames, we had not quite 50, 44 of those events. Cedar Rapids had just under 40, so quite a bit. We get to the last 50 years of the 20th century, and the numbers have dropped down to half of what they were before, even less than half of what they were before. And so far in the 21st century, we've had none. Even that cold snap we had before Christmas doesn't qualify by this standard. Now, I could have perhaps changed the standard a bit so that got included, but if I did, then all these things would shoot up to higher numbers as well. The key point is that not only has it been getting warmer on average, but the severe cold weather has been disappearing as we've gone forward in time. Now let's look at summer. Now your summer, this is the same difference, 1986 to 2016 minus the first 60 years of the 20th century. And now you can see for Iowa, large parts of it have had cooler temperatures. So what the heck is this warming I'm talking about? It's cooler temperatures. Well, I like to show this because it illustrates the fact that the climate system is more complicated than simply temperature changes, and there's a lot that goes on, and you have to think about, in any given local situation, you have to think about what contributes to causing the climate in that particular place. So, yeah, temperatures have been flat, maybe even a little bit cooler than they were going back well into the 20th century. So what's going on with that? And why am I saying that's tied in with global warming? Well, it helps to look at what's happening with water in the atmosphere. This figure here shows the trends in specific humidity. So humidity in the atmosphere for this period that's fairly recent, just 1985 to 2014. But what you see here is over this large part of the Midwest, the atmosphere has been getting more humid. Why is it getting more humid? Well, we get a lot of our moisture from the Gulf of Mexico. There's this flow in the atmosphere that brings moisture up into the middle of the United States, and it's actually very important for us because that flow of moisture is what allows places like Iowa to have substantial agriculture that's rain-fed without irrigation. We're in the middle of a continent, far from the oceans, and it could be pretty dry here. It could be dry like it is farther west. But because of that current of air that brings moisture from the Gulf of Mexico, we can have rain-fed agriculture, and agriculture that requires a substantial amount of rainfall for that matter too. So that flow of moisture has been increasing because the Gulf of Mexico has been getting warmer. And that means there's more moisture that can evaporate from the Gulf of Mexico and get pumped up to our part of the world. And when you have more moisture, you can have more precipitation. So what I have here is the year-by-year total precipitation for Marshalltown, Iowa, so not far from here, starting in 1893. This goes up to 2019, and there is darker shading for years where the annual total was above 40 inches, lighter shading when the annual total was less than 40 inches. And if you look at the first 70 years or so of this record, there are 11 years where you had more than 40 inches of rainfall in a given year. If you go to the last 56 years, you have almost twice as many. So rainfall has been increasing as well as the humidity. Rainfall means that it's been getting wetter here, and there's a couple of cooling factors that come into play with that. First of all, when it's raining, it's cloudy, so the clouds block the sun, so you get less heating of the ground. Another factor comes into play is when the ground is more moist, you get evaporation that also cools. And you can think about this if you go into a pool in the summertime, step out of the pool, you can start to feel a chill. And that chill is because there's water evaporating off of you, and that evaporation is taking heat away from your body. So the same thing is happening here, that with more moisture on the ground, we get more of that evaporative cooling, as they call it. So these two factors have come together, the cloudiness, the moisture on the ground, to cause temperatures where we are to be about the same as they were 100 years ago, and maybe even slightly cooler. So the point here is we have to think about the climate system as a whole, that what's going on here is very much tied in with what's going on in other parts of our planet. In this case, what's going on here in Iowa is very much tied in with what has been happening in the Gulf of Mexico. Okay, what do we expect to happen? The challenge here, of course, is how do climate scientists diagnose climate change? How do we actually figure out what's going to happen in the future? There's only one planet, the one we live on, so how can we test hypotheses about the climate? We can't just do something with our planet and then say, okay, well, that's what's going to happen, then go back in time and make another change and see what's going to happen. So there's various things that we do. We look at observed behavior, and in particular, we look at short-term climate perturbations, like what happens when a volcano erupts. What happens to our temperatures when that happens? Well, we know that causes the planet to cool off a little bit, actually, when we get some of these major volcanoes. So we can look, and also we can look at the long-term trends as well. We also rely on fundamental physical theory. We try to understand what's going on. I'll get a little bit technical here, but what goes on with the physics of our climate system. How do these processes work? And we rely on just some basic understanding, some basic conservation laws, like conservation of energy and things like that, to help us understand how these changes are occurring. And then we use these things called climate simulation models. We try to pack everything we know into these complex models, and I'll show you this on the next figure. These computer simulations of our climate, and we try to put as much into them. In our most sophisticated versions, we put as much into them as we think we know about what's important for the climate system. And we then run those, we run them forward in time. We also test them by running them for past periods to see if we can replicate, say, the ice ages, things of that nature, just to verify that, yes, these are capturing climate changes, both going backwards in time and also what might be happening in the future. And they're very complicated. As you can see, there's various parts to these. We have the atmosphere, we have the oceans, we have the land, we have rivers, lakes, the biosphere comes into play, snow and ice cover, and there's all these little details which you probably can't read, but there are all these different little factors that get put in together that interact with each other. Very complicated, can be very expensive to run on a computer, it can take a long time to get multi-decadal simulations, but nonetheless they're a great tool, but they require a lot of analysis as well to make sure that we can really trust what they're telling us, and that's where the fundamental theory also comes into play. We run these far off into the future by making assumptions about what the greenhouse gas changes might be, these so-called different scenarios, and we work with different scenarios that are based on some estimate or hypothesis about how humans are going to respond to climate change, how humans are going to act to reduce the emission of greenhouse gases or not, and try to understand what that might all produce for us in the future. So looking at scenarios, scenarios like that, there's some things that we can talk about. This is projected change in precipitation sort of 2041 to 2070, so a little bit more than mid-century, relative to the last 30 years of the 20th century under one of these scenarios. And what we see that for Iowa here, this is the precipitation change, increase in overall rainfall, heavy precipitation, which is a number of days with heavy precipitation here, really not showing much of a change. More rainfall, but it's not, at least in this one analysis, no increase in heavy precipitation, but the tendency for longer dry periods, number of days, how many days of really dry weather. So some of that I talked about earlier coming into play here, at least with this particular set of climate simulations. So this gives us some indication of what's happening possibly for Iowa in the future. Maybe what's of more interest in some ways, because we're an agricultural state, this shows here what the soil moisture changes end of the 21st century compared to the end of the 20th century. And where we are here, you see these deep reds, and those dots say that it's a very reliable result by some measure, that different models are producing the same result. And we see that there's a great tendency for significant drying, longer dry periods, and also greater evaporation because it's warmer, so the atmosphere can just draw more moisture out of the ground. So that is another possible change for us going off into the future. We have to think about this in terms of how we can respond, how we can adapt, and also what might motivate us to try to do something to prevent that from happening in the first place. And then another factor, more extreme heat for Iowa, projected change in the number of days above 90 degrees Fahrenheit by mid-21st century. Historically, we've had 1976 to 2005, we've had about 23 days here in Des Moines above 90 degrees Fahrenheit. If we go off into the future, depending on which scenario we follow, one that has high emissions, not much being done to restrict the increase in carbon dioxide and other greenhouse gases, we get almost 3 times as many of those hot days defined as days above 90 degrees Fahrenheit. But even with this low emissions scenario, we still get a substantial increase. This all comes from this thing called the Iowa Climate Statement. Some of you may be familiar with it. There's a group that puts out this statement every year. It's been happening for over 10 years now, talking about some aspect of climate change. It was originally started to provide a message to presidential candidates coming around for the Iowa caucuses in late 2011, I believe it was. And there's been a new statement put out every year. I've played a role in a little bit with some of these statements, but these are things that are really nice to look at. They talk about different aspects of what climate change means for Iowa. Well worth looking into if you get the chance. The Iowa Climate Statement. You can do a Google search on that and find the whole series. And I also want to point out that I've been talking a lot about physical science, but other disciplines have an important role here, and it starts to get into this whole notion that it takes a village, that it takes all of us to bring the expertise we have. This is an example here. Craig Anderson is a well-recognized professor of psychology here at Iowa State, and this other fellow, Andreas Miles Novello, was a postdoc working with him. They wrote a book talking about climate change and human behavior. What they're getting at is that increase in hot days can lead to a lot of stress, and that stress can end up having all sorts of negative impacts on societal interactions, different groups, maybe erupting in bad ways and things like that. So the point here, this is a lead-in to other things I'm going to talk about. I could talk on and on and on about the physical science, but there's other factors that are very important if we're going to actually address this problem, if we're going to address it in terms of trying to adapt to what's coming, but also to hopefully work together to mitigate those changes so that we don't get the most severe changes occurring. So we have choices we can make, and I've implied that a little bit already. What's showing on this graph here is this is the increase, the cumulative increase in carbon dioxide emissions from 1870 onwards, when we feel like we could get a handle on how much was being emitted by how much coal was being burned, and eventually also how much petroleum was being burned. The cumulative increase starting in 1870, here on the y-axis is the temperature change relative to this time period, 1861 to 1880. So what you see here is this upward line. This is 2010 here. This is way back in 1890 here. An upward line. As one increases, the other increases as well. The temperatures go up. If we go off into the future, we have all sorts of different scenarios that I mentioned that we can follow. There's a low emission scenario. There's something that's more medium, and then some higher emission scenarios. And the arrows here are drawn at where we would be in the year 2100 following each of these different scenarios. And so obviously these ones that have higher numbers on them are involve more and more greenhouse gases getting into the atmosphere, and things are getting warmer. So we have these choices. It depends on what we do. Do we act to restrict the amount of greenhouse gases in the atmosphere, maybe even starting to sequester some of that excess carbon dioxide, which is something that agriculture can play a role in? Or are we less restrictive? And there's this RCP 8.5 way up on the top there, just says we don't do anything. Everything just keeps growing and growing. In fact, some people have said things are going to get so bad climate-wise that we actually could never even follow that scenario all the way to the end of the 21st century, because the global economy is going to start to break down with all the heat waves and things of that nature, the dry spells, fires that break out, etc. We'll never even achieve that. But assuming we could, we end up getting a much warmer planet, over 4.5 degrees warmer compared to pre-industrial times. So how can we work together? Because we did, as I've been saying, we need to work together in various ways. And again, it takes all sorts of types of experience. In that previous slide, I talked about how psychology comes into play. But it's much more than just psychology. It's much more than just academic disciplines that are important here. So how do we get community concerns engaged in this? This is sort of the old model of how you would work with our climate research. You'd take this large volume of data that we can generate with these computer simulations. We can get scads and scads, hordes and hordes of data. For those of you that are experienced with working with large data sets, we're talking about gigabytes and petabytes of data. Lots and lots of numbers, and we can get numbers, we can get some results, and researchers can then analyze it, dig into it, feel very happy that all these numbers have been produced. But for everybody else, basically, people just get snowed under. It's like, what do I do with all these numbers? What do they mean to me? How do I know what assumptions went into producing these numbers? Why should I trust them? So the question here is how to produce information that is relevant to different community groups, that's credible, that it can be believed, that you trust it, and that it actually gives you some guidance on how to actually engage in actionable. So how do we do that? This old method just doesn't work. I mean, you just can't connect up with people in a meaningful way. So something that has been emerging in recent years, I hope you can see these arrows, co-creating knowledge, co-production of climate information, which means that we all have to work together. And I can't just put on my white lab coat and get my clipboard and talk as a climate scientist and tell you what the truth is about everything. That's going to be utterly meaningless. We need to work together. I need to understand where you're coming from, what your concerns are, what you value, and what your expertise is, and then we can start talking together and we can learn from each other. We have to learn from each other. So there's an emphasis on all of this in relationships, in equity, creativity by everybody's expertise, and values that people bring to the table. And what's shown here are these different groups of people, and even this is a little bit, breaks it down a little bit too much into separate parts, but there are these people that produce climate data, there's scientists who do research on it, tell us what seems credible or not credible, and then also various users, government agencies, non-governmental organizations, industries, etc. And they're all interacting with each other, as indicated by these arrows, and at the same time they're all working together to arrive at what is this climate information that actually is something that's credible, relevant, and actionable. An approach to doing this co-creation pathway is by storytelling, which is something I'm going to be leading into here. It allows us for providing diverse ways of knowing, recognizing that people have different ways of understanding the world they live in. It can connect personal experiences and local knowledge with the scientific systems. If we set this up right, and we're talking together and engaged in meaningful dialogue, we could take those personal experiences, those personal recollections, values, and we could connect it up with what we know about the science of the climate system. And in doing so, listening to stories, it can foster creativity, it can foster connections because people communicate so well by stories, and that relationship building that is so important here. And that's what's suggested a bit by this diagram here. So, together with Linda Schenk and Christy Franz, two people I mentioned on my very first slide, we've developed this storytelling tool. It's called the Community Environment Model. And what you're seeing here is what somebody sees on a laptop. This can be run on a laptop. It is very simple. In fact, it's trivially simple in many respects. You see these little agents that represent humans running around. These are various controls that a person can use to set different simulations in this model, and then there's all these little graphs that tell us about how things are changing, like how much polluted water is being generated, how much erosion is occurring, etc. So I want you to contrast this now. I showed you those climate simulation models that were very complex, take up huge amounts of computer time, produce large numbers of data, and this is like trivially simple, contrasting with those, and you say, how can something so simple be of help? This is a cartoon in many respects. But a key factor here is that it allows people to tell their own stories. It's very accessible. Those big, complex climate models are so complex that even somebody who's deeply trained in the field like myself has trouble understanding everything that's going on in them. This is very simple, very straightforward. People can run it on their own laptop. They can make changes so they can control it. They can see what happens when they make those changes. They have control. It's accessible. People can work with it. And so they can start to trust something with it. But what's even more important is it starts to get them to think about the stories that are relevant to them in terms of the environment that they're living in here. So the simplicity is actually a real virtue compared to those very complex models. And a lot of this comes from Linda, again, her scholarship is in English, but especially in Shakespeare and Elizabethan England. And she's brought a lot of lessons that she learned about storytelling from Shakespeare. And an example of this is storytelling lesson I've got here. The question I'm asking you is, why are the families feuding so intensely in Romeo and Juliet? So just take a moment to think about that. And the answer is, we don't know. Shakespeare never tells us. He purposely leaves out that bit of information, just like in other plays and other Renaissance storytellers, purposely left out certain bits of information. It's left out, if he told us why those families were feuding, you might start to take sides. Then you start to lose track of the two star-crossed lovers that are really supposed to be the central part of the story and the tragedy that occurs. It also allows, among other things, it allows Romeo and Juliet to be adapted for other settings, like West Side Story. And also, perhaps more important, it helps make the whole story accessible to our own personal lives. Many of us, I'm sure, have experienced family disputes along the way. And if you haven't, that's great. Congratulations. But many do. And so you can start to relate this to your own personal life, your own personal story, by seeing what's going on and seeing what the outcomes are when you have these disputes that don't get resolved. So this whole lesson in storytelling from Shakespeare. And that leads into this whole issue of trying to engage meaningfully with our community partners. Again, kind of repeating what I said before, there's a goal of fostering relationships, equity, creativity, and a recognition of the values that everybody brings to the table. It involves listening to partner stories. What was impactful, memorable, weather, and climate? And we climate scientists have our ideas of what might be impactful weather and climate, but that's limited because you've got to pay attention to what's important for the community partners you're working with. And this leads to this thing that some people have called a cognitive ecosystem. Shakespeare had that with his acting company. If you recall reading a play of Shakespeare's, it's very sparse in its stage directions. And that's because he worked with this theater company that was working together all the time. They developed a sense of what it meant to work with each other. He didn't have to give detailed instructions. He didn't have to be a director. In fact, there was no director for Shakespeare's plays. They learned how to work together. They developed that sense of a community that some people have called a cognitive ecosystem. And then in doing so, with his plays, he could start to bring his audience into that cognitive ecosystem as well. They would start to see how they fit into the stories he's telling. And so that's what we're trying to do in our work here is with our community partners is develop that same common sense of understanding of working together where we recognize what everybody is bringing to the table and that everybody has an important story to tell and that everybody's values, concerns are all equally important. And so the motivation in all of this is to create meaningful climate storylines, and I'll talk a little bit more about that on the further slides. Some details about how Linda and I have worked together to bring Shakespeare into all of this is this little paper we wrote a year ago about co-producing storylines with stakeholders using lessons in collaborative storytelling from William Shakespeare. But how is that done? So this very simple tool, the gaps then become space for stakeholder stories. That simplification, the simplified way this works gives people a chance to say, oh, okay, they start to think about what is important to them in their environment. So we call it an evocative tool. It's not like this is telling them the complete details of what climate change is all about. It's a tool to get people to start thinking about what their story is, what's important to them, and then we have to make sure we listen. And I would say that oftentimes it's hard for an academic like me to listen because we're taught to just tell our knowledge to everybody and expect everybody to want to listen, whereas we need to step back and listen to what other people are saying. And that's really part of the whole, what I would call a fairly recent approach to understanding how you work with communities to arrive at relevant information that helps people engage in action themselves. So this model, its simplicity is really a very important aspect of what is all about here. So, climate model stories. So ultimately we want to tell, once we hear other people's stories and we hear what's important to them, we want to take stories from our climate simulations, our climate models, and say, okay, these are the stories that we have that can help you understand what the future holds based on your experiences and what's important for you. The earliest paper that I'm aware of that talked about this was this one called Tales of Future Weather, and I think that sort of captures that notion of a story. They tried to talk about some important weather event in current climate, and then they tried to use some climate simulations to show what that weather event would be like in the future, how it would change. Maybe there might be more rain falling out of the sky, or maybe the heat spells would be longer or more intense, things like that. And more detailed physical statement here, a physically self-consistent unfolding of past events or plausible future events or pathways. So one way or another, what is the story that we're picking up that's relevant to the people we're working with? And so when we engage with our community partners, key question is what are memorable, impactful weather or climate events? And it may not be what we climate scientists might consider to be something important like super heavy precipitation. It might be something more mundane, as I'll show you in the next, some subsequent slides. And on the side, we also want to know how well do the climate models we work with, those simulations, represent these events. We want to make sure that we can really trust what our simulations are telling us. And there's a lot of detailed analysis that goes into doing that to make sure that we can feel like it really is physically accurate as much as possible. So the way we do this is we use this thing called object-oriented analysis. We look for objects in our simulations depending on how we want to define it. We're using some software that some colleagues of mine, Paul Ulrich and Colin Zarzicki, developed called Tempest Extremes. And as perhaps implied by the name, they developed that software to track tropical storms. So tropical tempests, if you will. And these are just some tracks for those tropical storms that they would get from their analyses. We use it differently here. What we're doing is we're looking for, in the example I'll show you, objects of rainfall. Rainfall that exceeds some threshold. And we want to see that it exceeds that threshold and how many neighboring locations also exceed that threshold, neighboring in space or neighboring in time. Maybe it's just one location that has this rainfall exceeding a particular threshold. So we get those objects and we interpret those as rainfall events, and those events yield those events, they yield event storylines. So we can talk about episodes of a certain type of precipitation and what it is in contemporary climate, what it is in future climate. We've done this with various types of thresholds, different fields. We've looked at heat stress in plants. We've looked at dry periods, a number of things, and also how they might coincide and what that means when you have two of these types of events occurring at the same time. But what I want to talk about here today, first of all, we focus on this north-central U.S. region here in our analyses. There's a scientific basis for why we have that particular region and why the U.S. is divided up in various ways. But the key point here for tonight is just that we're talking about this upper Midwest region. And what we're looking at here in this example comes out of this is a subset of that region now where we're focusing on something that is essentially Iowa in the data we're working with. And our partners in this case are women farmland owners. What's going on here is, this comes especially from work that Linda has done. Women own or co-own over half the farmland in Iowa, but they're often marginalized in terms of to what extent they have any say or control over what's going on the farmland. They often feel very beholden, because they may not be farming the land themselves, they may feel very beholden to the renters. And they don't want to upset the renter, because if they lose the renter, then they don't have that revenue coming from that farmland. They have to go out and start trying to find somebody else. So we've been working with them. We've been trying to find out what's of interest to them on the farmland that they work with. And also, as part of this, trying to make sure that they start to understand that they do have expertise, they do have knowledge that they can bring to the table, and they can work with whoever is farming their land. It might be their own land, or that they can work with people that are renting the land from them and try to develop more sustainable ways of working on that farmland that actually can be responsive to climate change as well. So the particular event here, it comes about from them recognizing that erosion is very important to them. They can see erosion quite directly by just looking at their farmland and seeing the change in the color of the soil. So it's something that really resonated with them. So it's not something that I would have thought about at first in quite the same way. We went and talked with people who are agricultural experts on erosion, and they told us, yes, you can have, if you get this sort of steady drip of rain falling in the springtime when the ground is bare, you can get substantial erosion. It's not simply just these big gully washers that come along, but it's that slower, smaller amount of rainfall that you just get these events occurring, and it just starts to gradually leach the soil away. And it's important in the springtime before the crops emerge, when the ground is warmed up enough so that you can get rainfall, or when the climate is warmed up enough so you can get rainfall, but the crops have not emerged yet that might hold that soil in place. So that meant that we focused on the months of February, March, and April, and we looked at what is fairly modest amount of rainfall, certainly not something that we would consider to be a really heavy, extreme type of rainfall, 1¼ inches of rain falling in a day. So our events were daily precipitation greater than or equal to 1¼ inches in some space-time volume. That is to say, there's some continuity in space, but also continuity in time. And we did this looking at two different simulations of contemporary climate and then those same simulations, what they produced for future climate. So these heavy lines here are what they produced for the number of events occurring over a 20-year period in the month of February, March, and April. And then the lighter shades, which are these lines up here, are what was happening in the future climate. And generally speaking, for the same color, there's always an upward shift. This projection is not showing actually very clearly that this is the lighter shade and this is the darker shade, but this is the future climate, this is the contemporary climate, future climate. And equally, so you see a shift upwards, and equally important, these arrows are suggesting that what was occurring in the month of April is now shifting to be 2 weeks earlier. What was occurring in March is shifting to be 2 weeks earlier as well, suggested by this. We're only showing dots for just the month of February, March, and April as a whole, but there's a suggestion that things are going to be happening earlier. So this all becomes very relevant for them to be thinking about what's going to happen with my farmland. There's already this issue of erosion they're facing as they start to look toward the future. And granted, this is well off into the future. This is mid-century. But the trend that they see is something that says, oh, I'm going to have to be this is not going to go away. I have to be thinking more and more about it. And among other things, you start to think about what are possible responses. In this case, key response that many of you probably have heard about is planting of cover crops, which would help hold the soil in place before the crops that you are trying to grow start to emerge. There's one example. But the key thing here is that we've been trying to develop this cognitive ecosystem with these women, and in doing so, they directed us towards a type of climate behavior that was not something that climate scientists typically think about. We don't typically pay too much attention to rainfall events. For daily rainfall, it's just 1 1/4 inches. More often, we tend to look at things that are much more extreme because they're much more impactful, at least on a short term. But it's this steady drip that comes along that is very important. So again, it's part of this recognition of we have to listen, and when we listen carefully, we come to understand what's really important, and we can then start to have some motivation for achieving some kind of action. And in a couple of instances, the women have been motivated enough by talking among their group to go out and start talking with their renter, and they've been starting to get some steps towards actually planting cover crops in this case as a response to that, which also has some other benefits that I won't get into because I'm not a farming expert, but it all revolves around this notion of soil health and how you improve soil health while also reducing erosion. So you could have a climate storyline coming from all that, and this picture isn't showing up very clearly, but it's indicating the erosion that you're getting when you have this steady rainfall, and I'm sorry that it's not quite as clear as I'd like it to be. But you could come up with a storyline that relatively modest precipitation events will occur more frequently before crop emergence. The overall pattern will shift approximately 2 weeks earlier in the spring. Now, you might be able to plant 2 weeks earlier in the spring as well in a warmer climate, but you still have to deal with the fact that there's going to be this rainfall. This steady drip is not going to just disappear on you. Okay. Whoops. Okay. So, opportunities, just to quickly finish up here. Many of you know about this. Many of you know more details about it than I do, actually, but City of Ames is trying to develop a climate action plan. They've gotten some input from the community. I would say a lot more input is needed. It's still a work in progress. There are these things called the 6 big moves, which are these different areas of trying to respond to climate change, doing some things like shifting more and more to renewable energy so that we're helping to mitigate the problem, but also doing other things like reduced waste emissions, net zero new construction, building retrofits, et cetera. Ways of responding to the changing climate in a way that hopefully mitigates the climate change by reducing the greenhouse gas emissions that come from our city. So please keep your eyes open for any opportunity to give input on this. There has been this supplemental input committee that's been working with the people developing this. I know they've tried to solicit input, especially the whole organizing committee. Talk to your city councilors. Let them know that what concerns you. There's a lot of details in all of these that still have to be worked out. And what's the best way forward for the city in all of these are details that still need to be worked out. And your input, what concerns you, what are your values, should be important to them, and especially to the city councilors, because they need your vote. So you should be able to get their ear. Another thing that probably doesn't work directly for all of you, but maybe you've got children or grandchildren. Here at Iowa State University, we've got this new major that's been approved last summer by the Board of Regents, a climate science major, where we're really at the cutting edge on this. We looked around to see who else was doing something like this around the country, and there really wasn't much of anything. And there's opportunities here for actually getting a degree in climate science with various pathways, recognizing that, again, it's not about the pure science, although certainly you can do a pathway that focuses on the science itself, but other issues like science communication, sustainability design and planning, all these things that involve how do you interact with a community around you, how do you get everybody working together. So there's various pathways, and these pathways are a recognition that this is not just a simple problem that you can have a bunch of scientists getting together and saying this is what we need to do. You need to have everybody working together on it. So please, I've got some further information on this. If you've got grandchild or whatever child that might be interested in this, let me know. I've got some information I can hand out. And with that, I will say thank you. This again is that paper that I talked about before, and this is the graphical abstract from that paper, sort of showing how the puzzle comes together when you have all these different groups working together. So thank you for your time and attention.
Well, thank you. I hope you take some questions.
Oh yeah, of course.
All right. Any questions for Bill?
Yeah.
Regarding the erosion and increased erosion, is there likely to be an impact upon dead zones in the Gulf of Mexico?
Well, yeah, I would say, yeah. Well, obviously, it's the erosion is a key part of it, but there's obviously things like what the farmers put on the land that gets washed off with that erosion. The nutrients, the excessive nutrients that then end up creating that dead zone. That's not my expertise, but that's my understanding of how it works. So yes, if you hold the land in place, then there's less that's running off into the rivers. And so in principle, it should contribute to lessening that dead zone. Yeah, great question. But that also, again, I talked about the Gulf of Mexico affecting us. Go the other direction, we're affecting the Gulf of Mexico. Again, showing that interconnectedness of what goes on in the climate system, and that you have to think about the system as a whole to hopefully arrive at a clear understanding of what's happening. Excellent question.
I have a question relating to I was fascinated by your remarks on tales or stories of a future climate. I'm watching the city work on its 40-year plan. Mm-hmm. And it seems like the assumption is that the next 40 years are going to be pretty much like they've always, the last 40 years. So where do we get, who is there a source where we can get credible, database, scientifically valid tales of a future climate? Is anybody working on that?
Some of what I've talked about is related to that, but we'd have to do some more specific analyses. What is it that's relevant? Are we concerned about flooding? Mm-hmm. Probably. Are we concerned about heat waves? Probably. Yeah, I saw that 40-year plan, and it almost seemed like disconnected from talking about climate, all while the city's talking about this climate action plan, and you're just wondering, well, wait a minute, how do they...
Apparently the thought is they're going to try and merge them up at some point, but I don't know.
Yeah.
But I think it would be more interesting if we had really persuasive stories of what might be happening in Ames 30, 40 years from now. And so we could say, okay, well, we're going to have a plan to deal with that.
Yeah, no, I would agree that we have to be mindful of how the climate around us is going to change, and what does that mean for any development that goes on here, including what the population change will be. There's some parts of the country where I expect the population is perhaps going to decrease, like the Southwest, because climate models over many generations have shown the southwestern United States getting drier and drier. And we see the problems right now with the Colorado River. The long-term trend appears to be one where it's going to get drier. So how are you going to support a population living there? What this all means for the city of Ames, I don't know for sure, but it's the kind of thing that needs discussion. And again, some of this what comes into play is what are community concerns? What are the values of the people in the community? What do they want to see in a community with that backdrop of changing climate going
Seems
on?
to me it's an opportunity for a novelist to get together with a geological scientist and work up a compelling tale of what we.
And I know there's some who've tried to do things like that, not so much for where we live, but that's there. But clearly, yeah, one thing I would say that at least some on the city council have recognized is that any plan that's developed has to be an adaptive plan, that you don't just say, this is what we're going to be doing for the next 30, 40 years. You've got a goal, you've got initial steps that might carry farther forward into the future as well, but you've always got to be reviewing it and seeing, okay, are we going in the right direction? Are there better opportunities for us now? Maybe new technology has come along that's better, or maybe what we're doing is working really nicely, even better than we expected, or maybe it's working worse than we had thought. So it's got to be adaptive one way or another, so it can be changing and flexible, and it has to be mindful of what the environment is going to be that it's operating in, certainly. Yeah.
Do the models that you're looking at, do they incorporate the possible positive feedback loops like permafrost, melting, things like that?
Yes, the global models do. I mean, the simulations that I showed you there were from these things called regional models, which use the global models to provide conditions for the regional models, but they include all of those different types of feedbacks. And of course, the most important feedback is the fact that when the atmosphere warms up, it has more water vapor in it. And water vapor is actually the primary greenhouse gas in our atmosphere. But people don't talk about it in the same way because we can't control it. It's a response to the temperatures going up, and when we've got a planet that's over 2/3 covered with water, there's always going to be a source overall for that. So yeah, they do try to take into account those feedbacks. As those models have gotten more and more sophisticated over the years, they've tried to be more inclusive of all of those different factors. Now, as I think about it, permafrost, I think they have it, but I'm not sure that they fully capture everything that goes on with methane release from it. Although I know people would have been working on trying to estimate what that would be. So again, they try to be as inclusive as possible. They try to focus, a lot of attention focuses on what people think are the most important things to put in there that maybe are missing right now. Getting vegetation that interacts with the climate system is very important because that controls how much water evaporates into the atmosphere. So yeah, when I was in graduate school or shortly after, I could sit down with what was considered a state of the science global climate model, and I could go through every line of code and I would understand exactly what they're doing. I can't do that anymore. I mean, they've gotten to be so complex. Even if I had the time to go through and look at every line of code, I still wouldn't have a good sense of what they were trying to do. You got to start to trust that other people are doing things appropriately. But even then, you always have to analyze what's being produced by these models. Does it make good physical, biological, biochemistry sense? You always need to have that. Otherwise, and I've seen some simulations that look a little screwy to me. And so I start to feel like, I don't think I can trust what they're doing because there's some things that don't make sense. I mean, maybe it's telling me something that's going to be very different happening in the future, but your first glance is, something that looks a little weird to that, so you don't really trust it. Yeah, you had a question.
I think it's very clear that the current rise in temperature is due to human interaction and human behavior. But my question is, but through the years, I'm thinking about the ice ages and things like that. There was change that was not related to human behavior.
Right.
And I'm wondering if that's something that we're fighting against. If there were continued change that is also in the works, in addition to our human behavior.
Yeah, no, I mean, very important that yes, there are natural changes that have occurred. You go back long enough to certain periods when dinosaurs were around, it was actually warmer than it is now, and then we got to this epoch where ice ages started to occur with certain regularity. And you go back about 50 years ago, some people were speculating that maybe we were going to start heading back towards an ice age, just looking at the long-term record. And yeah, so that could be happening. I think an important factor here now is when you look at those changes, they occurred relatively slowly compared to what's happening now. So a key difference is that these are changes caused by humans that are occurring much more rapidly than, at least as far as we can tell, with any of those natural changes that occurred. And so, in fact, one person I know, who's actually the professor in college who actually got me moving in this direction, he did some study way back when that indicated that maybe we might have been heading perhaps slowly back towards another ice age, but we kicked ourselves out of that cycle by virtue of this global warming that just took us out of that cyclical behavior, which wasn't part of the whole Earth history. I think it was, I forget what, I think it was maybe about 1 million or so years ago when the Ice Age and interglacial periods started happening. So there's all sorts of things that have obviously happened without humans doing anything. And it's been very useful for us to study those and try to understand what was tied in with those changes that was maybe related to greenhouse gases, among other things, and why did the changes occur with the magnitude they did. And as I mentioned early on, we also test our climate simulations by running them against some of those earlier periods. Can we reproduce what we think was the climate of those earlier periods? And I know you go back about 50, 60 years ago and the models we had couldn't do that. So it was very useful for just pointing out that there are things that we weren't getting quite right in our climate simulations at that point. These days, do much better job at it. It's not an area I work in, so I'm not going to say how perfect they are, but we've learned a lot by trying to do that and trying to understand what the natural processes are, and then that helps inform us to make sure that when we start to put in this human influence, that we really have a good gauge of what the human influence really is versus what's happening naturally. Yeah, no, that's a great question. All right, since you haven't asked one yet, then I'll go back to you.
You mentioned about the number of days above 90 degrees going up. And I know this is not exactly your area of expertise, but I've also heard that the nighttime lows, if they don't get low enough, that actually has a major impact on agriculture. What can you talk about that?
You know, I actually had a student do something for a senior thesis last fall on that topic. And, you know, I can't remember exactly what came out of it. But yeah, there is an increase in the nighttime lows. And yes, that's not good for agriculture because it needs to have temperatures go down below a certain level. We've also looked at heat stress when daytime highs get above, I think it's 30 Fahrenheit, it's about 90 degrees Fahrenheit. But yeah, there is this issue that if the nighttime temperatures don't go down far enough, it affects some of the biogeochemical processes going on in the plants, and I can't explain it myself, but it has to do with how you end up getting carbon fixed in the plants and everything, like in the seeds and everything. And if you don't have that, then you're undermining that whole process as well. And that would be a concern as well going off into the future, that it's not just the high temperatures which are bad, but also the low temperatures. And people have talked about, in that context, about how different agricultural zones and natural ecosystems we're going to be shifting northwards to may stay within. You know, with agriculture, you can do that because you can just say, I'm going to plant this now instead of that. Or you can, you know, there's a lot of work that's been done with new seed varieties that might accomplish some of that. But you know, there's a limit to how much you can do that too, because you also need the rainfall and things of that nature. Or people have talked about ecosystems that are shifting up mountainsides to stay cool, but once you get to the top of the mountain, you can't go anywhere anymore, so then you would just lose it. So yeah, I mean, these are all important questions, definitely. Yeah.
I have a comment relative to the climate action plan and this point about talking to the city council. In this November, 5 city council people will be up for election. 2 of those will be in areas that are non-incumbents. Will be someone new will be there. So I think we need people to run for office in addition to talking to their city council person.
Sure. No. Yeah, no, that's true. Very important point. That there's various ways to be active in civic affairs, and yeah, running for city council is definitely one of them. So, all very important. Oh, no.
Okay. Well, I think we'll let you go then.
All right.
All
Well.
right? Thank you very much.
Yeah,
I'm really reticent to ask the question, but I'm just curious, okay? I look at a weather map, and the storms seem to be so widespread. Now, I don't remember ever that happening 50, 60 years ago. I know the rain is more, but...
Yeah, I think if you're talking about like winter storms, well, we did get them. I think maybe we didn't have as much with satellite information and things pulling it together. Still a question, there's a lot of year-by-year fluctuations, as I talked about, and I don't know how much of this is tied in with those kinds of fluctuations. I can't answer your question, actually, but certainly there's been more severe weather that's been coming along, and I have a sense that's not just purely coincidental. I think that when you have more energy in the climate system because it's warmer, more water vapor, you can get more severe weather occurring. What's happening like the past few days, that gets into this question of Arctic air spilling over, and that's somewhat controversial right now. Some people think we'll get more of that happening as we go into the future. Other people say, no, you're not looking at the full picture. It's still an object of study. But nonetheless, with the Arctic getting warmer, we're not going to get those cold snaps like we got a century ago, because the air that does come from the Arctic, even though it can be pretty cold, is not as cold as it once was. And then the other thing is you always got to, I know some people worry about some of the language that gets used that is getting into general public usage now, like people talk about a bomb cyclone. That's actually terminology that I think one of my professors in graduate school developed that was intended to be just talked about among the scientists, or these things called atmospheric rivers. Very colorful language, but it could also be very misleading. And if you start to hear more language like that you didn't hear 10, 20, 50 years ago, then that might also just amplify what you've been observing. I'm not saying that what you're observing is wrong, but there's a lot of different things going on, and some of it has to do with how it's presented in the news as well. Yeah.
That brings me to a question. Do you feel our weather people they've got so much sophisticated equipment anymore, but I don't feel they're any better today than somebody looking out the window.
Well, there's a limit to how far you can forecast weather into the future, even if you have the most precise data. And we're certainly not at that limit. This was actually one of my other professors in grad school actually developed many years ago. The most we could ever possibly hope to forecast weather day by day into the future is about 2 weeks, and obviously we're not up to that limit. I think if you look at the statistics, you might find this hard to believe, but actually there has been a slow improvement in what we could say going more and more days into the future. But a real challenge, just as it was back then, is rainfall, snowfall, because the storm only has to change its track just a little bit, and you can go from getting a deluge to getting almost nothing. And so that problem is still there. It's still a challenge, and that may be, I'm not saying that's all you're reacting to, but that may be part of it. When I look at projected forecasts, say 5-6 days into the future, I'll see what they're indicating the temperatures might be as an approximation. I don't pay too much attention to the precipitation that far into the future because things keep fluctuating, and it all has to do with just how accurately we can run these numerical weather forecast models. So there has been progress, but it's been very slow, and so what you're seeing certainly would fit with the experience of most people, I agree.
So do you think the interstate highway systems have any effect on weather? Because it just seems like there's, north of 30, north of 80, some things.
I think some of that has to do with the fact that those are convenient landmarks. And because I'll hear people talk about north of US 30 or north of Highway 20. Yeah, and so it's a landmark that people can readily recognize. And so I don't think the highway system itself has any direct influence.
I think the roads were put in along geological ways.
Well,
and that represents high spots, low spots. And
yeah.
That's where the weather's going to happen.
Well, you might know better than I do in that regard. there are things, urban heat islands, as people talk about, do have an impact on weather. When you get these urban areas that develop, they can actually have an impact on what kind of weather actually makes its way into the city or not. I'm not an expert on that either, but I have heard people talk about it. But that's about major urban centers, not roadways. Roadways are really, in and of themselves, are too small to have much of a influence on the weather. But they are convenient landmarks for telling people this is what's going to happen to the north of this, east of this, whatever. Yeah. Yeah.
Talking about people telling their individual stories and relating to the subject in that way seems a long distance from what we perceive as the need for federal policies on this issue.
Yeah. Well, yeah, we need everything. I mean, part of it is, of course, just how much people understand what the impact of climate change is going to be for them and for their children and their children's children. And that has to be expressed to our elected officials or to run for office yourself. And one of the problems is I'm going to get on a soapbox here for a little bit, but oftentimes the politicians are often influenced by something other than the voters, which they should be influenced by. Yeah, money, yes, exactly. I've written more than once to our U.S. senators. Charles Grassley seems to recognize that the science is telling us something. Joni Ernst says, oh, well, I recognize that climate is changing, but there's a lot of uncertainty about it. And I said, well, that's a weird answer. Then because you're basically giving the line that the fossil fuel companies have given us for decades. And then I saw that she had gotten some sizable campaign contributions from people who are executives in the fossil fuel industry. And she claims that she reads everybody's message sent to her, but I sent a message to her once, got a response, and then I refuted everything she said, and I got the exact same response back. So she clearly... So I finished my second letter to her by saying, don't bother responding again because I already read your response twice. You know? So yes, I mean, as you said, the money comes into play, and it's hard to counteract that, but this is where citizens have to speak up, and especially if someone sees that they're not going to get reelected, maybe they might start to change their tune on that. Of course, the challenge is there's a lot of issues out there to deal with. It's not like climate change is the one and only issue. But nonetheless, it's a vital issue to be considering. And there are things like this, the Citizens Climate Lobby, which is, as I understand it, has been, I've tried to connect up with it, and I just haven't had the time, which is my fault. But they seem to have been effective, at least in some instances, with pushing legislation along, getting things established, showing that there's public support that really wants to see these things done. If you look at polls, the vast majority of Americans say, yes, humans are causing climate to change, but when you look at the legislative action, until Biden came along and got this act passed, which I'm sure if he loses the next election or whoever Democrat is running will probably start to get supplanted somehow in the other direction, just like we heard that Jimmy Carter had put solar panels on the White House and then Ronald Reagan took it off. There's political things that go on with it too, unfortunately, which is frustrating because you'd like to think that everybody's paying attention to what is very solid science. Thank you for coming out tonight. I hope we get home safely. Just watch carefully where you're walking. Please, it's also very cold out tonight, so make sure